All right, in part 2, we're going to look at more kinematics. This time, though, I'm going to just pause the video, and if you want to have a go at this question, feel free. I'll just zoom out a bit more. Okay, so the following velocity time graph, which is, of course, this one over here, is racing car over a short course. Which of the following could be the acceleration time graph? Okay, acceleration time graph. So I'm going to pause there and get you to have a go at it. All right, so everyone shout out the answer. E. The answer is E, and that is pretty straightforward stuff. Why can I rule out D?
Because it's still positive.
Because it's positive, that's right. Why can I rule out A? Because it's just negative at the start. Why can I rule out B? Because it's silly. Why can I rule out C? Because it's positive at the end. Beautiful. Well done. Good stuff. Aha! Now this is the sort of stuff that is the start of chapter 10. Now I'm going to get you to have a look at this, and we're basically looking at x as a function of t. In other words, position, I want you to think as position as x, but when we think position, you cannot think distance. It is displacement, isn't it? And displacement is what we call a what quantity? It's a vector quantity. We can go forwards, we can go backwards, it has an associated direction, and of course sometimes your distance and displacement can be the same if you're travelling in one direction. But of course in specialist maths a lot of the time we travel in several directions. So I'm going to pause the video now. I'm going to get you to have a go at this. And remember that this is from the 2004 exam. This is still pre-CAS. Okay? So I'll get you to try to do it without a CAS. Away you go. Guys, I'm just going to give you the hint that velocity equals dx dt, and you need to know that. And this is the pretty simple stuff. This is like early chapter 10 stuff. Velocity equals dx dt. So the velocity is equal to 2.5, derivative of cos is minus sine, and the minus 9 over 2 sine of t over 2. You okay with that? Now, what's the minimum? The minimum is when this value is obviously going to be, or the sine of t on 2 is going to be 1. So it's going to be 2.5 minus 4.5, which is equal to negative 2. Okay with that? Well, Nikita, you look a bit worried. All good? Sure? Okay. Shh. All right. Now, shh. For this question, we can ask you equations of motion, by the way. Now, those equations of motion are v equals u plus at. V squared equals u squared plus 2as or x. I'm going to call it x. And then I've got x is equal to ut plus a half at squared. And forget the other one because you only use that on several occasions. Let's start with those for now. So I'm going to pause this video. I'd like you to have a go at that. But remember, when can I get Nikita to tell me, when can you use those formulas on the right-hand side that I've just written here?
Constant acceleration.
Only when there's a constant acceleration. Yes? If there's not a constant acceleration, then we have to use those things on the formula sheet because acceleration can change as a function of time and acceleration can change as a function of velocity. And they're the two tricky parts about this chapter 10. So don't think that this stuff's all easy. It's not. But at the moment, this stuff definitely should be. Now just remember that your formulas are on your formula sheet. Okay, you can see them there. They are there. You don't have to remember them, whether it's exam 1 or exam 2. You won't get too many of them, to be honest. You'll get more of those sort of questions. Now, what I would like to say is that a balloon is rising vertically at a constant speed of 21... Why is it doing this? 21 meters per second. Now, the thing is that I've decided that 21 meters per second is up. Okay? Okay, so 21 meters per second, up is positive. Okay? It's really important for you to define that, because if you don't start using your positive, so I'm saying up is positive and down is negative. Now, a balloon is rising vertically at a constant speed of 21 meters per second. A stone is dropped from the balloon when it is h meters above the ground. So, what would be my acceleration when it's left? Now, it says here negative. Now, I think in this exam it says to use 10, okay?
Yeah, do we use 10 or
No, we use 9.8 because this was an old exam. They say use 10, okay? No. Now we use 9.8, but this exam was 10, okay? Just because this was an old one. All right? Now, what am I using though? What am I finding? Like, don't I want to find h? Like, can't I find like h? Isn't that like the distance? Like, isn't that this one? Do I know the time? So can't I use x is equal to ut plus a half at squared? Yep.
So I was just going to say they use 9.8 for this one.
Yeah, they use 9.8.
Oh, did they?
Yeah.
Oh, my apologies. My apologies. Okay, sorry. I thought that they would have used that. But okay, a equals negative 9.8. You okay with that though? Okay. So x though is h. Is that right? But what speed do they drop the rock at? 21 times 10. 21 times 10. Yeah, we'll use down as positive. Why not? Plus a half. I've got negative 9.8 times 10 squared, which is equal to, I've got 210 minus 490, which is equal to negative 280, which means the height is 280. Is that right? Yes. Okay. What have I done wrong there? So, what have I done wrong in my working here? Nothing?
You can define x as negative h.
Yes. Yeah.
What you've worked out is like the point it hits 10 seconds later is 280 meters below where you dropped it from.
Yeah. Okay. Cool. All right. Now, this time I want you to be able to use. Now think about it. A particle moves in a straight line when its displacement from a fixed origin is x meters, its velocity is v, and acceleration is a. Given that a is equal to 16x and v is equal to minus 5 when x equals 0, the relationship between v and x. Now, I need you to remember your formulas. What are your formulas? Is a dv dx? Is a dv dx? A is equal to v dv dx. Okay, so this is the things that we need to. Now, I'm going to pause this video again, and I would like you to. Now, we've just discussed. Now, remember, we're trying to work our way through this together. This is the first time you've seen these formulas. But it's the hardest part of the whole chapter, is understanding which formula to use where. Luke, can you explain what you're doing?
Well, because acceleration is a function of x,
Yep.
that means we can't use a equals v dv dx. Instead, we have to use the formula a equals d of half v squared
Yep.
dx.
So, if the thing is that if a is a function of x, then we can't really use that, can we? Now, generally speaking, if a is a function of x, then a lot of the time we can use, what's the other one, Luke? D by dx of a half v squared. Okay? Now, I'll explain to where that comes from later. Okay, because I'll confuse you too much if I introduce it now. So I'm going to pause this video, and now I want you to use that the acceleration, because it's as a function of x, is equal to that. All right? Away you go. Resume there. Shh. And I'm going to play there. Now, all right, now just quickly, I want you to see this. If the acceleration is equal to the derivative with respect to x of a half v squared, then, and I basically sort of just told you here that, like, this is sort of where this comes from. Okay? This is where this comes from. This thing here, basically. All right? That now, I won't go into the science of it yet. I don't want to confuse you too much. But what we can say is that if d by dx is a half v squared is equal to a, then if I antiderive a, with respect to x, okay, then that's actually going to give me a half v squared. Does that make sense? Yes. Okay. Now, therefore, what we've got is we've got 8x, so we've got the antiderivative of 16x is equal to a half v squared. Okay? Now, plus, so therefore I'm going to do it this side. Now, remember that when we do this, we've got this, that's going to give me 8x squared plus c is equal to a half v squared. We do have a constant, but when v is equal to minus 5, x is equal to 0, so that's going to imply for me that, so I'm just going to skip a step, c is equal to 25 on 2. Now, we're not quite done yet though, are we? Because what have we got? We want to find v. So, now what we've got is we've got 8x squared plus 25 on 2 is equal to a half v squared. We want to find v in terms of x. So I have to do a little bit of rearranging here. I'm going to multiply both sides by 2. So therefore I've got 16x squared plus 25 is equal to v squared. And then I'm going to say that v is equal to the square root, now plus minus, be careful, don't remove any of that, of 16x squared plus 25. Now, 16x squared plus 25. Now, 16x squared plus 25, 16x squared, we can rule out these three, can't we? Would you agree? But the initial conditions, x equals 0, v equals minus 5. How can you possibly have a negative if it was this one? So the answer is C. Okay, so we have to, using the initial conditions, it's this one. Because initial conditions. Can you see how differential equations and all of that sort of stuff, anti-differentiation is so important to why we're learning this stuff now? All right. This time, we're going to do this one. Now, be careful. I'm going to give you a little hint that if we've got acceleration or velocity as a function of, what is it in this case? A function of x, then a lot of the time you're using this, a half v squared d by dx is equal to a. All right? Now, and of course we anti-differentiate and differentiate accordingly. All right, I'm going to pause this video now, and I'd like you to have a go at it, please. Resume. All right, well, in this one, and the hint was, because we have acceleration or velocity as a function of x, then a lot of the time this one works pretty well. Okay? So what I've got is I've got a half... Oh, dear. Oh, dear!
It existed 400 million years ago.
Oh, dear! You have just seen the first page of component 1 of your SAC.
And it's on video.
And it's on video!
So we can get the backstory.
It was not component 2. No, I'll leave it. I'll leave it. It rewards people for watching my videos. All right, I better get out of emails. All right, okay. All right, you ready? Shh, we're still on YouTube, by the way. So what I've got is a half v squared because I'm anti-differentiating. Okay, so if I'm anti-differentiating, that's going to give me a half v squared is equal to, I've got 2 over 1 minus x squared. Is that right? No, because I'm squaring it. So a half v squared, I'm just writing, a half v squared is equal to a half of 4, yeah. Okay, so I've skipped a step, haven't I? Now, what's the derivative with respect to x of 2 over 1 minus x squared? Well, I guess you got to just have to do that the good old-fashioned way, don't you? We're going to have to do, I could do the chain rule, the product rule, or the quotient rule. Well, I'm just going to do derivative of 2 is 0 times that, so that's going to be that. And the derivative of that is 2 times 1 minus x squared. What's the derivative of that to the power of... Okay, look. What I'm going to do is I'm going to do this. Sorry, my bad. D by dx, I'm having a bad day today, of 2... 1 minus x squared to the negative 1. Okay? That's what I'm going to do. Now, of course, when I'm doing that, I need to do the derivative of what's inside there, the chain rule, which is negative 2x. Okay? And then I have to multiply it by this thing here, which is negative 1. And then I have to multiply that by 2. And then I have to drop the power by 1. 1 minus x squared on 2, which is equal to, is that an x? Yeah, it is. 4x. Shh. Is equal to 4x on 1 minus x squared on 2. Is that what you got? Is the answer C? Well done. Sorry, I've done a lot of maths today. All right, now, let's have a look at this. Let's have a look at this one. A particle travelling in a straight line has a velocity. Its acceleration is given by this. The time taken in seconds for the velocity to decrease from 2 to 1 is... I'm going to stop this video and I'm going to get you to think about it because we've got to use integration and differentiation, anti-differentiation, differential equations to solve these sort of things. Okay, you ready? Okay, now this is a really easy question because we don't have to actually evaluate anything, but think about it. If I had dy dx, and then I had as a function of y, then I'd have to do something, wouldn't I? The old flipperoonie. So what I'm saying then is that we want to find, we actually have to go dt dv is equal to v squared minus 9 over 3. Now, that means that gets rid of that gets rid of that, and that gets rid of that. So you see instantly, if you, for whatever reason, didn't get it and then had to guess, and you got a 1 in 2 chance. Now, the thing is, though, that it says here, the time taken in seconds for the velocity to decrease from 2 to 1. Well, that means this is starting at 2, going to 1. Start, finish. So the answer is? B. Well done. Can I get a show of hands of students that got that in about 30 seconds?
Not 30, like 40.
All right. I personally, I think you good students, the students who have studied hard, eventually you'll get that in like 20 seconds. Not yet, because we just only just started this stuff. I think you're doing fantastically well. I'm so proud of you. All right. I won't do that one for the time being. Let's do this one. Shh. All right. Now, I'm going to give you, this is from 2006. You have CAS calculator from 2006. There is no point doing any practice exams prior to 2006. So, when you get your practice exams very early next term, you're going to have 2006, 7, 8, 9, 10, 11, 12, 13, 14 to work from. Okay? And then, of course, you'll get your NEEP and your MAV and all of that sort of stuff. But you can use a CAS calculator, so get your CAS calculator out if it helps. I'm going to give you a minute and a half. So I'm going to pause this now. Okay, so this is what I'm thinking. This is how I would do it. By the way, A as a function of X, can be that one we talked about, which is d by dx of a half v squared. But it just doesn't really work out that well. But v dv dx, let's have a look at v dv dx. It's sine of 2x, and dv dx, isn't that 2 cos of 2x? Okay, so I've got 2 sine of 2x, cos of 2x. Isn't that a double angle formula? Okay, which is sine of? There you go. So, I've just done that question without a calculator. Well done. Did you do that, Jordan?
Yeah, I just didn't simplify the end.
Now, I can tell you, I reckon that question could have been done in 30 seconds, but that's what I'm saying. That's robot time. Okay? Robot time. I'm not expecting you to be robots now. All right. Final question and final part of the video, which is going for 22 minutes at the moment.
What year is this?
This is it's 2008 exam. Okay. Pausing, and this is the last question. I'm going to give you a minute and a half, just like what I would in a multiple choice. Ready, set, shh. All right, shh. Shh. So I think you've learnt that I'm going to time it. Let's see what the time is, 22:50. I'm going to say A is equal to V dV dx. That was time up. That was your minute and a half time up, by the way. Okay. Oh, I'm running out of time here. Oh, okay. A V dV dx, which is inverse sine of x. And isn't that over the square root of 1 minus x squared?
Yeah.
All right. Just done it in about 30 seconds. All right. Now, I'm going to stop this video now because we'll be on recess in a moment. But how are we feeling about... I'm just going to ask a few people. How are we feeling about the start of kinematics, Dean?
Good.
Good. What's the thing you found the hardest?
Understanding some of these formulas like
The acceleration formulas?
Yes, A equals d dx.
Okay. What about you, Yanlin? What are some of the things that you found struggles so far?
Like figuring out what to do with the formulas.
With the formulas, good, because that's what everyone struggles with. Lachlan, have you found this pretty easy?
Yeah, it's been easy. Working out when to use d of the half v squared is kind
Yes,
of tricky.
beautiful. All right, guys, well done. That was a really good lesson.